GPIO Over IP, AMWA IS-07, is a general-purpose API that easily scales with Rick Siegel. He manages the system consulting arm of Riedel Communications' North American team, is responsible for coordinating other system consultants, providing technical support to the sales staff, conducting training sessions, and representing Riedel on industry panels. He has previously served as SVP of Sales and Marketing for Aurora Multimedia, Director of Business Development for Zantac Corporation, and not the antacid, right? Zantac with an X, and Product Engineering Manager at Otari MFG. Siegel graduated from the Polytechnic University of New York with a BS degree in electrical engineering. So please give a warm welcome to Rick.
Thank you, Thomas, and Chris, thanks for that little segue into my presentation here. Arne Bonninghoff, our head of IP Research Division in Germany, was supposed to be here, and last minute he couldn't make it, so hopefully I bring some of his wisdom into these words here. So as Thomas said, basically what I want to talk about is AMWA IS IS-07 as a general purpose API that can easily scale. What I want to start with is an introduction into GPIO and where it is right now and where it needs to go. So these are basically simple connections for general purpose usage, and they trigger actions across multiple vendors. So basically it's just a voltage that can go between two different vendors, and that vendor distinguishes what that voltage is going to do on the other end. It can also indicate feedback back, putting an LED on or an LED off, saying a system is on or off. These are Boolean in nature, so basically it's in a high-low voltage and on-off, or in software that would be a true-false. And traditionally, these are connected as a one-to-one relationship. So they might exist as a D-sub connector on one device, but then that might have to split off to multiple devices, send one GPI to one place and an output to another place, and so on and so forth. Or you can carry multiple of these GPIOs over that single connector to another device to enable multiple GPIOs between those two devices. So there is no IP in this ecosystem, and if you want to control multiple devices, you need additional cabling. And if you want to actually take these GPIOs and move them from one device to another, you literally have to move that cable over. So that's not to say that there is no Ethernet for GPIOs. There are adapter devices that exist on the market today and have been there for a number of years. But these basically are proprietary. They're still point-to-point, and it's a fixed relation between these two devices. So basically, there's no dynamic reconfiguration as well. So if I wanted to change again from one control room controlling something in a studio to another studio, or another studio to another control room, these physically have to be reconfigured. So in essence, it's basically just replacing a GPIO cable with a Cat5 cable. The one thing that you are gaining in this is the ease of cabling. I don't have to run new cabling to another room if there's a network switch that's there. I just need to reconfigure it to the device in that other area. So there are some benefits of that. Now let's take a look at NMOS IS-04 and 05, and basically what changes are being done there to facilitate IS-07. So with NMOS IS-04, you have the ability to expose all the elements and all your devices within your IP ecosystem. And there's 3 or 4 different attributes of this. You have nodes, which are your logical host, and then that node has a device. And that device can actually have either inputs or outputs or both, which are your senders or receivers. And then those basically connect to each other through flows. So the flows basically are representations of the content. There's no direct relationship between physical cables here, which is very, very good. So there is no SDI cable, coaxial cable for your SDI video, or an XLR cable for the audio. Basically what you're doing is you're exposing all these different elements into the network and basically virtualizing your broadcast workspace. Then IS-05 is how we're going to make the connections between these two devices, between your senders and receivers. So what we add here is we add a control user interface on top of your IS-04 registry. And basically what happens here, now your senders and receivers are going to be exposed to this control user interface, and I can basically select a sender and a receiver and make a connection there. And what happens is, through this IS-05 mechanism, it's going to do an HTTP GET to get the SDP file, which is a description of that sender or that output, and then basically enable that sender, so now it starts flowing on the network, and then it's going to push that SDP to a receiver, and then the receiver is going to do an IGMP join to actually accept that flow, and then the connection is made. So one thing that IS-05 also has is the ability to do bulk senders and patch connections, and we're going to elaborate on this as we start to bring in IS-07 here. And speaking of IS-07, so there were changes to IS-04 in version 1.3 where it's capable of more than just on-off states, which is necessary for GPIOs. But what we have here now is event types, and there's 4 different states within that event type. So you have Boolean, which is your on-off state for your tally signals. You can do strings, such as UMDs, descriptions of devices. You can actually represent colors here to trigger different colors on a user interface. You also have numbers, and then you give meaning to these numbers within the event states. So basically, a number can be a temperature, it can be a gain, encoder value, or a metering value. And then you also have a type of enum, which is one state, which is basically a collection of states. So think of a studio that might be totally off air, or it might be or not in use at all, or it might be on air, or it might be off air. So these can be represented by a single number. So it could be 1 for no session, or 2 for on air, and a 3 for off air. But there's a lot of other states that are happening within there to actually facilitate that whole studio to be on air or off air. So IS-04 senders can now send states of events. And similarly, you can expose all these different elements in these resources through NMOS Explorer, just like an audio, video, or sender. So think of some type of control panel that has lots of buttons and lots of different LEDs. We can take each of those different resources and expose them through IS-04, and through IS-05, some higher level control system might be able to say, hey, you know what? I have something that requires an on-off. I want to actually connect to that button and give that button a different use than it was intended for. So within the IS-07 type definitions, within IS-04 for audio and video, you have SDP files, session description protocols, that explain what that sender or receiver is and what type of attributes. Within IS-07, we have a JSON object that actually facilitates the same thing. So on the receiver side, it's going to say, okay, I'm going to be accepting things. It might be Boolean, true, false, or an on-off. It might be exist within a range of values. It might have a list of values, a 1, 2, or 3. And basically, when a number comes in or a message comes in, I can actually give a unit of measure to that. So if a number comes in, I can say, oh, that's a temperature number, and it's going to be in Fahrenheit or Celsius. So the message only carries value. So on the JSON object on the receiver side gives that message meaning. So the message is very, very small in nature, doesn't eat up a lot of bandwidth, and it's basically just going to have its state, whether it's on or off or some type of number, and then that receiver is actually going to give it meaning. So the two devices, you know, we talk about senders and receivers for audio and video. We talk about emitters within IS-07 and absorbers. So emitter is something that triggers an event. It's an output that goes somewhere and triggers an event, and the absorber gives meaning to that event. So the IS-07 message, it's in a JSON message format, so it's simple, human, readable. It's a unique identity, and when we press a button to trigger some type of event, we have to lock that into a moment in time. So just like, you know, when we're trying to keep audio and video in sync together, if I'm going to basically enable that camera to be on, that also has to be in sync as well. So it is tied to PTP, so all your messages within IS-07 are tied to PTP timestamp. So there's two mechanisms to transport these messages. One is WebSockets. WebSockets is more of a one-to-one correlation, such as a traditional GPIO. So basically, it's a direct connection between an emitter and an absorber. The absorber doesn't have to, or the emitter doesn't have to start a connection every time it needs to say something. So what happens is once this IS-05 makes this connection, there's a heartbeat from the absorber side that basically keeps that emitter open and keeps that connection active. So it's always waiting for another signal to come from that emitter. And with WebSockets, it makes it web compatible, meaning that third-party people or even end users can create websites to integrate into a browser so that they might not even have another device. That website might actually be that emitter or that absorber device. So this actually creates multiple possibilities for the future. So you can create a website and click on a button within that web page, and that button is your actual trigger or your emitter to some other fixed device that's the absorber, and the absorber can actually respond to that using that API to give visual feedback directly into that web page. And you can also make this securable through WebSocket Secure. So the other mechanism for transport within IS-07 is message queue telemetry transport, MQTT. And what this allows you to do is to have that one-to-many connection, something that we really, it was very difficult with standard GPIOs to do this. So this is a basic information and technology protocol, and it's used by billions of smart home devices. So think of you drive home to your house, and as the map shows that you're in proximity of your house, you might start an event within that house that turns the lights on, turns the air conditioner on, puts your TV on, sets it to NBC, and then everybody's happy when they walk in. So these are securable through secured brokers as well. So a broker stands in the middle between these emitters and absorbers. So the emitter sends a message to the MQTT broker, and then the broker basically exposes these, and the absorbers basically subscribe to that broker to get its information. So in this way, we can actually send multiple messages to multiple devices simultaneously. So scalability is a very big thing and something that was very limiting in traditional GPIOs. So there's three areas that we have to look into for scalability. One is in the registration of the IS-04, connection management within IS-05, and we were just talking about the message transport, the WebSockets, and the MQTT transport mechanism. So let's start with registration. We did some tests here, and Sony actually conducted some tests last year by taking a single node and device and exposing multiple elements within that. So let's say a camera. A camera basically has video sender. It might have an audio sender as well with a microphone on it, and it has intercom in there as well, so it has an audio receiver and another audio sender. So it has basically 6 attributes that it needs to register within IS-04. The typical mechanism for doing this is to basically post that one resource and then wait for a response and a confirmation back from the registry server that it's there, and then go on to the second one. So it's very serial in nature. With a camera, that's okay. So with 6 different attributes that you want to register, that doesn't take much time at all. It's within milliseconds. But if we start to visualize this into control systems, let's say a control panel might have 120 different resources that it has to register. If we basically did a test with this with 520 resources to try to see how much we can scale this. So what we did was we'd go and post that single resource, wait for a confirmation, post a second one, third one, and so on and so forth. And that basically took 13 seconds or more to actually complete that mechanism. Now, the first time that you do that is the last time that you do that, but that's still a long time for something to actually register. So what we did was as opposed to doing everything serial, we try to do things parallel. So basically take all of these resources at one time and expose them and try to post them to the register server and not have to wait for a response back before we actually sent another one. So basically all those other response messages come back afterwards, and that speeds up the process. You still do have to do your node and your device serial. You have to make sure that those are set in place first. Otherwise, these other resources that are tied to that device and that node don't know where to post themselves. So you do have to make sure that the node and the device come first, and then all the other attributes of that device go second. So we were able to do 520 resources within only 1.9 seconds versus 13 seconds. So the next thing with scalability is ISO 5. So as I mentioned before, ISO 5 has a bulk and patch mechanism where I can make bulk connections through the control system and then patch them all simultaneously. And this is a much more efficient mechanism, basically being milliseconds as opposed to seconds to make all these different connections. And this is very needed, especially when we're changing, let's say, one control room tied to one studio, and then that studio is tied to another control room. You have to actually make a lot of different connections to make that happen. And then the third is the scalability to message transport, which we discussed before with Websockets and MQTT. So the messages are actually very, very small in nature. So they don't take up much bandwidth on the network. So when you have WebSockets, only one WebSocket per server device, it has some of its limitations because it is more of a point-to-point mechanism, but allows creating multiple connections from one device. So if one device can send out one emitter, one trigger, then the absorber that's accepting that can actually do multiple things within that event. And then we have MQTT, where you have a broker which needs to process a lot of devices. So testing that we've done basically indicates that you can do 50,000 messages per second through this mechanism. And one thing that we're looking into is having multiple brokers, which can actually facilitate lots and lots more messages and basically scale this to where it needs to be. So there's three different use cases that I'd like to talk about. One is basically a simple state, either a tally, something, an LED turning on or off from a camera. Basically an incremental temperature change, changing a temperature from 30 to 31 degrees. Or an audio clip, I'm waiting for audio to cross over a certain threshold, and then I'll actually turn my clip LED on. So that's one use case. Another use case is doing dynamic tally reconfiguration. So when we do tally within a control room, we have the vision mixer is going to choose a new camera. It has to first talk to the existing camera, shut its on-air LED off, turn the next one on, and then also talk to the multi-viewer as well. So it has to do simultaneous messages to multiple devices. The other thing is if all of a sudden one day we want that studio to be operated out of a different control room, then we have to actually change all those connections at one time in the, doing MQTT and bulk and patching within ISO 5 facilitates that mechanism. So let's take a look at a button panel. So a manufacturer might have created a button panel for one specific use, but through ISO 7, if they incorporate that API, that one specific use, maybe it was a control panel to talk to a specific router, they can now expose that control panel and let some other third-party control system actually utilize those attributes. So we can also expose the LEDs within there. It's not just the buttons. And if there's displays, we're actually trying to do testing with displays where we can expose the display and bring information back there as a feedback channel as well. This makes it vendor agnostic. So one vendor can create a control panel for one intended use, but now the end user, since it incorporates this API, can actually use that for multiple uses. And we can actually connect different devices to simple control panels. So either I can take a single control panel and take some of the buttons and tie it to one device, some buttons tie it to another device. That's something else that we can do within IS-07. So with small systems that have specific attributes, an on-off state or a temperature state or a fan being on or off, we actually wouldn't even need another control system, a third-party control system on there. Two devices, a device that basically has that power supply or that device is on or off, and something that needs to know whether that device is on or off. Using this API, they can speak to each other without having going through a third-party system. So extending on that and expanding on that, we can actually take all these simple states and you can envision a next generation SNMP trap through the IS-07 API to facilitate the same thing over the network. In conclusion, I'd just like to say IS-07 complements basically what we're doing in SMPTE 2110 and NMOS, and it's basically rounds everything out. As Chris said before in his presentation, one of the things that's needed as we move everything into a SMPTE 2110 ecosystem is we do need NMOS basically to expose all those elements on the network and to make logical connections, but we also need to bring in the GPIOs and everything else that we're doing within our workflow and bring that into the same environment. So it's basically true dynamic GPI usage, and it's enabling new dynamics and more efficient workflows because I can have one device that's in my control room that was intended for a single use, but if it's incorporating this API, I can extend that API to other devices and streamline my workflows and actually make better financial decisions as I'm moving forward. And thank you very much.
That was great, Rick. Thanks so much. Again, we've got a microphone in the center aisle if anybody would like to come up and ask Rick any questions. So Rick, I'm going to ask you a practical question. What is the current status in terms of like shipping products that do IS-07? Are we seeing anything at IBC?
At IBC, we were actually showing one of our panels talking to 4 different third-party systems. I believe Dataminer is here at the show, and they're going to be showing something here as well. There's nothing that I know that is officially released, but a lot of manufacturers are getting together, and we should be seeing something soon, hopefully this coming year.
Okay. Any questions for Rick? If not, we're ending a little early, so what we can do is are there any questions for any of our other speakers, for Nick and Thomas, or for Chris and Steve? If anybody would like to come up, yeah, please. And why don't we have all our presenters come on up.
Yeah, I had a question about the first presentation you did, guys. About drawings, because right now when you go to 2110, every device connects to a network switch, but when you go to see the operators, these drawings doesn't mean anything anymore. So what did you do to kind of roll that path?
Yeah, so you're talking specifically about work like documentation?
Yeah, exactly.
Yeah, so a great question, actually. That it was kind of one of the side benefits of the way that we built in these, like I called it this virtual loopback routing, is that thing really acts like a virtual device on the network. So we actually produce a significant amount of documentation that includes basically virtual single line drawings that include those virtual objects in there to describe signal path through the router, because like you point out, looking at a physical wire drawing is utterly meaningless.
Yeah.
So we have to work really hard to produce functional workflow documentation, and that thing has been a tool in that.
Okay. Pierre-Luc from CBC, by the way. Other question about the PowerPoint presentation you did with the CCUs and the cameras, because we have the same issues where within each control rooms, we're going to decide camera 1, 2, 3, 4 for each control rooms. Mm-hmm. But in the robo room, how do you manage the robotics that has a single numbering for the cameras,
Yep.
but then when you in the control rooms, it's 1, 2, 3, 4 every time. So how do you catch up?
Yep. This pretty simple answer is that in the so we have the centralized robos and centralized shading. They see both. So we have our multi-viewer support UMDs where they see, okay, this is PCR1's camera 1,
Yeah.
but it's also global CCU number 52. Okay. They see them both under the same one display, and they just need to be able to jump back and forth.
And they can load a multi-viewer layout that is consistent with the production control room that they're working with.
Yeah, and they see the same thing on their RCPs. They see that global name. So yeah, they just kind of have to live in both those worlds.
But there's limitation within the RCPs. I think you cannot go more than 99 or something like that. But it does because your RCP are you're controlling a CCU from a control room, so it means it's 1, 2, 3, 4.
Yep.
So it's not the same.
Well, so I mean, our RCPs see the way we set up the camera control network there is that all the cameras are on the same one camera control network. So absolutely, yes, we are subject to that extremely annoying arbitrary limitation of the number of devices supported there. Luckily, we have not hit that wall yet, though we're very close to it.
Okay.
So our two biggest facilities, which are New York and Telemundo Center, are coming in just under the wire.
Okay.
If anyone's listening, we look forward to improvement on that as well.
Thank you.
Thank you.